Alrighty, hey guys, tonight we're going to be learning about atomic orbitals. So atomic orbitals are all about quantum numbers and defining electrons and trying to determine which electron you're talking about in an atom. And so electrons can be described by four different factors, and these are called quantum numbers. The first one, N, is the energy level, and it's a number from 1 to 7, and it describes the approximate distance from the nucleus. Its maximum capacity of electrons for an atom at that energy level is 2n squared, and this energy level is determined based on the periodic table and what period they're in on the periodic table. So you can find out from the periodic table where your element is, what energy level it's going to be at, so what its N value is. So for example, potassium is found on the 4th period, so it's got an energy level of 4. Next we go to sublevel, which is L, and it is a range of numbers from 0 to 3, and it's N minus L, so your N level minus 1 gives you your sublevel. Now you might be wondering, okay, N can go up to 7, but our sublevels can only go up to 3. What the heck? And that's honestly just because there are only 4 different types of sublevels, S, P, D, or F. So once you get past 4, you still just have the S, P, D, and F. That's your only options. And these sublevels describe the different shape of the orbital. And again, like I said today, you do not need to memorize the shape. I will never ask you to draw the shape of an orbital. It's more important to me that you understand how many parts there are, not the actual shape. Next, the angular momentum, or M sub L. And this has a range, numerical range of -L to L. And it describes the location of the electron in the orbital. And we're going to get more into this when we specifically talk about M sub L. And then there's the spin, the final quantum number of M sub S. And the spin is either +0.5 or -0.5.
Do note the thing is not spinning.
And Mr. Fernandez would like me to note that the electron is not itself spinning. We're just describing it, which I will go into detail on that later. But it's either +0.5 or -0.5. But again, it's not actually spinning. Now, and it describes the air quote spin up or down of the electron in its orbital. Now, there's something important to remember about electrons, and that they are like snowflakes. No two can be the same. So no two electrons can have the same 4 quantum numbers. You can have the same 3, but you can't have that same 4th quantum number. So you can have the same N, L, and M sub L value, but your M sub S value needs to be different. It needs to be either +0.5 or -0.5. You can't have the same +0.5. It's not the same. Okay, so like I said, no two electrons can have the same 4 quantum numbers. So let's get a little more detail in on some of these quantum numbers. So energy level, N is equal to 1, and it can be found by looking at the periodic table, just like I said, and it's just by looking at the different periods and what level your element is falling on. And the row where the element is found in is the highest energy level, or the highest N value for the quantum numbers. So don't forget that just because potassium, K, is in energy level 4, it had to go through energy level 1, 2, and 3 in order to get to 4. So it has all of those electrons as well. So lithium is found in the 2nd row and has an N value of 2, but it also has 1. And like I said, potassium is found in the 4th row and has an N value of 4, but that doesn't discount the fact that it had to go through N equals 1, 2, and 3 before it could get to 4. Let's talk about some sublevels, or L. It's directly related to the energy level and describes the shape of the orbital. And so the sublevel options are from 0 to 3, and the value of the energy level describes how many sublevels there are, from 0 to N minus 1, corresponding with S, P, D, and F. So for example, L equals 0 is talking about an S orbital. L equal 1 corresponds to a P orbital, L equal to 2 corresponds to a D orbital, and L equal to 3 corresponds to an F orbital. Now what this means is that L lithium is N equals 2, so it has 2 sublevels. And it has N minus 1, so 2 minus 1 means it starts at the highest of L equals 1, and then it also has L equals 0, so it has an S and a P orbital. Whereas potassium has N equals 4, so it has 4 sublevels, and its highest is going to be 4 minus 1, which is 3, so its highest is going to be an F orbital, but it also has an SPD and an F. Let's talk about these sublevels, the shapes of them. So I said that you weren't ever going to have to draw them, but it's important that you know about them. So the shape of the sublevel tells you where those electrons can be. And so for an s orbital, you can have 2 electrons anywhere in this sphere. But when we talk about p orbitals, you're going to have kind of a dumbbell shape along the y-axis, the x-axis, and the z-axis. And so it creates these 6 options for your electrons to be in. And you can see that it gets more and more complicated the more orbitals you add. And it becomes very specific as to what location these electrons can be in the bigger your orbital type you have. So an F orbital has very specific locations that electrons can be, whereas an S orbital is kind of, it's somewhere in that sphere. And again, remember that L equals 0 is an s orbital, L equals 1 is a p orbital, L equal to 2 is a d orbital, and L equal to 3 is an f orbital. So let's talk about angular momentum, which is m sub L, and it describes the location of an electron within the sublevel, or which orbital it belongs in. So m sub L varies between negative L and L, and for any L, there are 2 L plus 1 orbitals in that sublevel. So for L equals 0, 2 times 0 plus 1 is 1 orbital. That's why an s orbital only has 1 orbital in that sublevel, whereas L equals 2, 2 times 2 is 4, plus 1 is 5. L equal to 2 is a d orbital, and they have 5 orbitals. So lithium has an L value of 0 and 1, so an M range of 0 and negative 1, 0, 1. So it has 3 orbitals. 3 orbitals plus 1 orbital is 4, which Li is N equals 2. I'm sorry, not N equals 2. If you have 2L times 1, you've got 1 orbital plus 3 orbitals. Or you have K has an L value of 0, 1, 2, or 3, so an S, P, D, and F orbital. That means that it has 1 orbital in the S, 3 in the P, 5 in the D, and 7 in the F. And this makes sense as there's 1 orbital for the S sublevel, 3 for the P, 5 for the D, and 7 for the F. And let's take a look at this, because that was all very confusing. So if L is 0 and M sub L is negative L to L, then the M L range would be 0. So the S sublevel has 1 orbital, because negative 0 to 0, that doesn't exist, so it's just 0. And an S orbital only has 1 location. It's 1 orbital, the 0 orbital. If L is 1 and M sub L is negative L to L, then the range would be negative 1, 0, 1. P sublevel would have 3 orbitals. And you have them here, negative 1, 0, and 1. If L is 2, the range is going to be negative 2 to 2, which would have 5 orbitals. So the D sublevel has negative 2, negative 1, 0, 1, and 2 sublevels. And L equals 3, or your F sublevel, has 7 orbitals, going from negative 3 to 3. So negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, and 2 electrons can go into each of these 2 orbitals, or locations for electrons. And it just kind of depends on where you are and what's going on as to whether you have an SPD or an F orbital. Okay, I'm going to let this sink in for a second. Now let's talk about spin. So spin is the magnetic property of an electron. It's not actually whether it's spinning, it's a magnetic property of an electron. We just describe it as spin up or spin down. And there are 2 directions for spin, up or down, plus a half or minus a half. And so it's the magnetic property of the electron. Don't really think of it as spinning. It's a magnetic property of the electron. And we just give it a sign of plus a half or minus a half. So let's do an example. And let's look at neon. So neon has 10 electrons. Its atomic number is 10, so it has 10 protons, so it has 10 electrons. And where that, it's also found in the second period, so its n value is 2. N value of 2 means that it has an L value of 0 and 1, so it fits in the s and p orbitals. And its m sub L range is going to be -1, 0, and 1 for the p orbital, or just 0 for the s orbital. And the m sub s is going to be +0.5 and -0.5. Now, remember, in order to get to 2n, it had to get through 1n at first, and the first level only has a 1s. So we have 2 electrons in the 1s, spin up and spin down. Then it also has a full 2s orbital. So spin up and spin down in the 2s, and that's a total of 4 electrons. Now it has 6 more electrons to deal with, and the p orbital has 3 orbitals. Each taking 2 electrons means that you can put a total of 6 electrons in that 2p orbital. And so that's where they all go. That's how you can account for all 10 of those. Now, each of those electrons is going to have a set of 4 quantum numbers. This electron right here, and I'm going to really quickly, sorry, I want to do a little writing here. Okay. Oh, I'm sorry, guys. I'm really sorry, and I would start recording again, but this is like the 3rd time that I've started recording. So we're gonna get through. Okay, here we go. Now, pen. Oh wait. Okay. So let's talk about this electron specifically right here. So this electron is going to have an n value of 1 because it's in our 1s orbital. It's going to have an L value because it's an s orbital of 0. And it's going to have an m sub L value, therefore, of 0. Now this one specifically is going to be -0.5, spin down. Now we could also describe this electron right here. It also would have an n value of 1, an L value of 0, and an m sub L value of 0, but it's got +0.5. Okay? So we're describing each of these electrons. And let's take a random one. Let's look at this one and try and figure out which one this belongs to. So it's got an n value of 2, so we know it's going to be either 2s or 2p. It's got an L value of 1. That corresponds to a p, so I know it's going to be one of these guys. And it's got an m sub L of 0, so we're going to go with -1, 0, 1. So -1, 0, or 1. So we're going to be talking about one of these two guys, because the m sub L is 0. And then it says -0.5, so it's going to be spin down. So we're actually specifically talking about that electron. Okay? Okay. So, and there are a total of 10 electrons that we've accounted for in here. Now I want to erase all of this, clear annotations. Okay. So, we can give examples like that where we can write out all the quantum numbers of a given element. Now, I would not ask too high up because that does, I mean, you get into a lot of electrons there, but you could do that. I could also ask you to describe and name the following quantum numbers. So if I asked you to describe n equals 4, L equals 0, m sub L equals 0, and m sub s is equal to ±0.5, I would tell you that that was an orbital in the 4th energy level, that it was the s sublevel, which means that its angular momentum, it only has one orbital, one s orbital, so the m sub L equals 0, and that in that orbital it can have 2 electrons of either a spin 1/2 or spin -1/2. So it's a 4s orbital, which is the s orbital in the 4th energy level with 2 possible electrons, either spin up or spin down. Or I could give you n equals 3, L equals 2, m sub L equals -2, -1, 0, 1, 2, and m sub s is equal to +0.5 or -0.5. Now this is going to be a 3rd energy level. L equals 2 means it's a d orbital, and d orbitals have 5 orbital options, each with a spin option of +0.5 or -0.5. So it's a 3d, which is a d sublevel in the 3rd energy level, with 5 possible d orbitals, each with 2 potential electron spins, either spin up or spin down. So I could ask you to kind of define that. Or I could ask you to give the values for the following orbitals. What's a 3p orbital? What are the quantum numbers for it? And so you would say that the n was 3 because it's a 3rd energy level. If it's p, that means the L is equal to 1, which means my m sub L is from -1 to 1, and my m sub S is plus a half or minus a half. So n would be 3, L would be 1, m sub L is -1, 0, 1, and then the m sub S would be plus a half or minus a half. And then I could describe a 5F. So n equals 5, L equals 3, m sub L is -3 to +3, and m sub S is plus a half or minus a half. Okay? Now we can do other things too, where I can ask you what would be the location of the outermost electron in bromine. So the 35th electron, where is that going to be? And you could give me the quantum numbers of that. And we'll go over examples like that in class. But I hope this helps. I'm sorry that it was a little bit jumbled, but we're going to talk more about it in class tomorrow and kind of go through all of this and talk about quantization and why that's happening. So I look forward to seeing you tomorrow. Have a good night. And now I have to stop, and I can't stop recording. I don't know what's happening. Oh, goodness. Sorry, guys. Ignore this. Where's my... There it is.